Welcome to Math 1324. This is section 2.4. We want to investigate polynomial functions and rational functions. Polynomial functions look like x raised to a power. It can have other terms in it, but they are nice powers. In the simplest cases, we could have f of x is x to an even number. Just that one piece. X squared, x to the fourth, x to the eighth, x to the 20th. All of those that look like x to an even power will basically look like a parabola. And on the two sides, the left and the right, the ends are up. It's growing toward plus infinity. If it is x to an odd power, x to the 1, x to the 3, x to the 5, x to the 101, it essentially looks like x cubed, where the left side is down and the right side is up. If there is a negative in the front of either one of these, then it's flipped over. So I could have it looks up or it's flipped over and both sides are down. If it's x to an odd with a negative in the front, left side is up, right side is down. That's going to become important in a few minutes. Now, some more information about polynomials. If it's a polynomial that has an even degree, it will cross the x-axis. The important thing here is cross. It can cross or touch or something an even number of times. So, for example, x to the sixth and some more terms. This is the highest power is x to an even. So, this function, if we graphed it, would cross the x-axis 0, 2, 4, or at most 6 times. If it's an odd degree, it has to cross an odd number of times. So f of x is x cubed plus 1. It's going to cross 1 or at most 3 times. But x cubed plus 1 is shifted up like this, crossing here at 1. And so you see it only crosses the x-axis one time. What else can we say? And that is a polynomial of a particular degree, n. So for example, x cubed has a degree of 3, x to the sixth has a degree of 6. Now, a polynomial of a degree n will have n minus 1 or less turning points, places where it turns around, it goes the other way. So, let's take a look at some of these places. Alright, let's look at this one here on the right here. Well, first off, notice where are the two ends? The two ends are down. Now, how could I get down? Let's see. Down was an even power flipped over, right? Remember back up here, let's go back and review for just a moment. Because you're thinking, what did he say? Remember this thing again? If it's even, they're both up. Or if it's negative even, they're both down. If it's odd, we got down and up. So keep that in mind when we're looking at the highest degree. Okay, back to our story here. So with both sides down, that has to be a degree that is even and flipped over. So what they're asking us is, what's the minimum degree that this polynomial could have? Well, let's see. And is the leading coefficient positive or negative? Well, we know it's negative because both ends are down, and that happens when it's a negative times x to the even. Now, in green here, see in green, we have what I would call these turning points, places where the graph turns. So there's 1, 2, 3 of those. Okay, so if I've got 3 turns, and how do we calculate these turns again? I forget. A polynomial of degree n will have n minus 1 or less turns. So if we have 3 turns, n minus 1 is 3, that means that the smallest degree where this could happen would be a 4. Okay? And what else could I say? See, it's also crossing 2 places. We already knew it was even, and we knew it's negative, and so our turnings were 3, so the only degree that fits is 4. All right, looking here at question 2, what can I say about this guy? Well, first off, let's look at the two ends. I got up and down. Certainly cannot be even because, well, even was either both up or both down. So this has to be an odd. But it's a flipped over odd. It's a minus 1 times x to an odd. So the leading coefficient is negative because it is flipped over. All right, what about crossing places? 1, 2, 3, 4, 5 crossings. How many turns? Let's see. A turn here, 1, turn 2, turn 3, turn 4. 4 turns. All right, so what's the minimum degree to do this? Well, let's see. 5 minus 1 is 4, which is the 4 turns. So it has to be a minimum degree of 5 or more. And that also matches with how many crossings that we had. All right, what about this one on the right here? Let's see. Both ends are up. That means it's a positive x to an even number. So degree must be even. So this is positive. How many crossings? 1, 2, 3, 4 crossings. All right, an even number of crossings. We kind of knew that because it is an even degree. How many turns? 1, 2, 3, 4, 5. So let's see, what minus 1 is 5? Well, that has to be 6. So the minimum degree is 6. All right, so that gives us what we know a little bit anyway about polynomial functions. All right, what about rational functions? What are these rational functions? Rational functions look like p of x over q of x. And both of these are polynomials. So, some examples, I could have 1 over x, 1 over x minus 2 squared. And here, x squared minus 4 over x minus 2. Now, you see these dotted lines I have on these first two. They are labeled VA as vertical asymptotes. They are places where the denominator is 0 and the top is not 0. So a vertical asymptote is where the function is undefined. And it's undefined in a way where the graph is running off to infinity. This one, it's at x equals 0. This one is whatever makes the bottom 0, which is 2. In this case, the two sides go up forever. Now, what about this guy? You might think, well, yeah, it's undefined at 2 because 2 minus 2 is 0. But why doesn't it blow up? Why doesn't it run off to infinity like these first two? And the reason it doesn't is because 2 also makes the top 0. So again, a vertical asymptote where the graph runs off to infinity happens where the bottom is 0 and the top is not. If both are 0, what typically happens is we have a blowout. There's just one spot that's not defined. All right, what about horizontal asymptotes? If you notice on these two graphs, they seem to be leveling off somewhere on the two sides. And this one is leveling off at y equals 0, which is the horizontal asymptote. So the question then becomes, okay, what happens on the two sides to these rational functions? Do they level off to 0? Do they level off to some number? Or do they just run off to infinity somehow? Well, it all depends on the degree of the top and the bottom. If the degree of the top is smaller than the bottom, again, the degree, the highest exponent. Here's an example. X to the 1 and an x2. Degree of the top is 1, degree of the bottom is 2. On the two sides, this graph levels off to the x-axis, which is y equals 0. If the degree on the top is bigger than the bottom, here's the case. X cubed over x to the 1. Top degree is 3, bigger than 1. So this thing does not have a horizontal asymptote. It's going to run off to infinity. And in the last case, what happens if the degrees match? Here, this is an x2 and x2. Both have a degree of 2, and so it levels off to the number 5/3. So there are only three things that can happen on the far left and the far right. Either it levels off to 0, runs off to infinity, or it levels off to a different number from 0. Okay, let's see. So in question 4, they give us this function and they're going to ask us all kinds of things about it. Where are the x-intercepts? Okay, well, x-intercepts are what would make it 0. Well, a fraction is only 0 if the top is 0. So I've got x plus 2 is 0, so x is minus 2. Okay, so this graph, whatever it looks like, will cross the x-axis at minus 2. What about the y-intercept? Okay, set x to 0. 0 plus 2, 0 minus 2, 2 over minus 2 is minus 1. Okay, so it's going to cross the y-axis at minus 1. What about the domain? Well, let's see. Domain is where is it defined? It has a denominator, and so I don't want this denominator to be 0. Let's see, x minus 2 not 0, so I don't want x to be 2. So the domain is everything except 2, which would be minus infinity to 2, union 2 to infinity. Okay, vertical asymptote. That's the place where the bottom is 0 and the top is not 0. Let's see. Our graph was x plus 2, x minus 2. So we know that 2 makes the bottom 0. 2 minus 2 is 0. But 2 plus 2 is 4. The top is not 0. Therefore, the vertical asymptote, is when x is 2. Okay. And what about the horizontal asymptote? Let's see. Degree of the top is 1. Degree of the bottom is 1. The 2 degrees are equal. Therefore, the graph will level off on the two sides to the number, which is the coefficients sitting here in the front. 1 and 1 is 1. So, the horizontal asymptote is y equals 1. Okay? Now, where is the graph? Well, let's see. What did I know? I knew it was going to level off to 1, so the graph levels off to 1 here. And on this side, it's going to level off to 1 as well. What else? We know it had a vertical asymptote at x equals 2, where it blows up. We knew it had to cross at minus 1 and minus 2. Well, therefore, it's got to keep running down here. You might say, well, how do you know it doesn't turn and come back up? Well, remember, we only had one x-intercept, and that was here at minus 2. And so if it crossed and came back up, we would have had another one. So it doesn't do that, and so here's our graph. So pretty clearly, no, the horizontal is wrong. That's not 1 like there, so that's off. Vertical here is in a negative side, and it's not, and so therefore it is B. All right, let's see for this one. We have f of x is 3x over x minus 2. X-intercepts, what makes the top 0? Well, let's see, that's x equals 0. Y-intercepts, set x to 0. 0 over negative 2 is 0. So what do those two things tell me? Well, it tells me that it's crossing through the origin. And that's the only place it crosses the x-axis. What about the domain? Well, I don't want the bottom to be 0, so everything except for 2. Vertical asymptotes. Well, let's see, we already saw 2 is bad, and 2 does not make the top 0. So, vertical asymptote is at 2. What about the horizontal? Let's see. Degree here is 1. Degree here is 1. The degrees match. Therefore, horizontal asymptote is 3. Okay, so put it all together. It's going to level off to 3. Yep. Crosses at the origin. That's the only place. Blows up here at 2. So the only way all that can be true is if the graph looks like that. So this guy is the wrong one. What's wrong with this guy? The horizontal is here, down too low, and it was supposed to be up at 3, like D. Okay, let's see. Question 6, we're looking for horizontal. That's it, horizontal. Well, let's see, degree of the top is 2, degree of the bottom is 2. So the horizontal asymptote will be just these two coefficients of 2/3. What about this one? We're looking for vertical asymptotes, places where the bottom is 0. Well, let's see, x squared minus 9 is 0, factors into plus 3 and minus 3. X squared minus 16 factors into 4 and minus 4. So we've got 4 asymptotes. 1, 2, 3, 4. Now be careful. It will give you trouble if you put them out of order, because it says write the 4 vertical asymptotes in order from left to right. Yes, that seems a bit picky, but that's just how they coded the problem. All right, what about this guy? Find the equation of any vertical asymptotes. Let's see, where is the bottom 0? Okay, let's see. First off, I want to factor the bottom. I can take an x out. Yeah, did that. X squared minus 9, did all that. Got that. Now you might say, okay, it's easy. We're done. The vertical asymptotes. When is the bottom 0? And that would be 0, minus 3, and 3. But wait, remember, a vertical asymptote must occur at a place where the top is not 0. That's why I factored the top as well, because yes, x equals 0 makes the bottom 0, but it also makes the top 0. So x equals 0 is not a vertical asymptote. The only vertical asymptotes are 3 and minus 3. And again, they want this business of leftmost and rightmost. And so that concludes our look at polynomial and rational functions.